Talk about shape of data distribution. Before we do so, let's talk about box plots. Here's the box plot that shows the ages of U.S. Vice President when they took office. From what I can tell, let's try to interpret this box plot. The minimum looks like right here. The maximum is right here, which looks like about 72. The median is right here. This is quartile 1, and this is quartile 3. So what is quartile 1 again? It is the median of the lower half. Quartile 3 is the median of the upper half. So what is the median? It is about 53. Quartile 1 is a little less than 50, so maybe 48. Quartile 3 is exactly 60. What's the maximum age? The greatest age seems like it's 71. What is the minimum age of a U.S. Vice President according to this? It's 36. And what is the IQR? That's the interquartile range. To find an interquartile range, you take the quartile 3, take quartile 1, that is the edges of this box, and you subtract it. So 60 take away 48, so the interquartile range is 12. Let's remind ourselves, what percent goes in each portion? Between 35 and 40, 36 to 48, this is 25% of the data was set in here. Between 48 to 53, 25% of the vice presidents were in there. Between 53 and 60, 25%. And between 60 to 72 or 71, 25%. That means if I got all the data, I broke them into quarters or quartiles, into fourths. 25% went here, 25% here, 25% here, 25% went there. So, I didn't know that we had questions about it. What percent of U.S. vice presidents were at least 60 when they took office? At least 60. So 60 or higher, 25%. What percent of U.S. vice presidents were between the ages of 49 and 60? So it's between here to here. That's 25, 25, 50% of it. Because I know a lot of kids get tricked because they look at it and say, wow, this is so long. This is a little less than half of it. No. In a box plot, it is broken by the periods. The gap between each period is 25%. All right, today we're going to talk about shape of data. So you're going to be getting histogram, dot plots, and box plots. You will be describing the picture. What does it look like to you? So before we do so, let's see if you can match these. The numbers that have no data value. So if it's empty, has no data value, which one would it be? Symmetry, gap, peak, or cluster? There will be a gap in it. The left side of the distribution looks like the right side. Symmetry. Guys, symmetrical. Did you know models are all, to be a professional model, you have to be symmetrical? They actually did a study. I think I read that somewhere. The most frequently occurring value. So which one occurs the most? It's the peak. Data that are grouped closely together. So it's a cluster. Have you ever eaten a nut cluster? That's like a cluster of nuts in caramel and chocolate. Really, really good. Or you hear a cluster of like Ebola cases where it's a bunch of people who have the same virus together. Where they cluster them together. Great movie, Quarantine. So, name the number of times you have been on a plane. So, let's use some numbers. Let's think of 18. No, that's way too much. Let's do 12. Let's do 7. Let's do 0, 1. Let's do 2. No, let's do 8 and 9. So, let's see. Is this a good amount of data? And let's take away. Yeah, that's good enough data. So, I already put them in order from least to greatest. All right. Can you create a histogram using this data? A histogram is a range. It's like a bar graph with a range. So, I'm going to do, 0 to 1, 2, 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 to, Don't have enough information here. So let's do 0 to 2. 0 to 2. Let's do 3 to 5, 6 to 8, 9 to 11, and 12 to 14. So let's go back to our previous data. So from this, how many 0 to 2 do you see? Between 0 and 2, there are 3. So 1, 2, 3, 4, 5. So there's 3. So I draw a bar. 3, these are the number of students. If I had room, I would label that. These are number of students, and these are plane rides. So as you can tell, 3 students rode the plane between 0 and 2, a range of that. 7, so there's no 3 and 5. There's 2 for 7 and 8. 9, there's 1. And for 12, there's 1. So that's the histogram. So how can you describe it? Is there a gap in here? Yes, there is a gap between 3 and 5. I'm going to write that down. Describe the shape. Symmetry. Do you see symmetry? Does the left side look like the right side? No, it does not. So I'm going to say no. Is there a peak where it's the highest point, like a mountain peak? Yes, it's between 0 and 2. Is there a cluster? If you look at here, there's a cluster of numbers together. From what I can tell, look at it, between 6 to 14, there's a cluster of numbers. And is there an outlier? Not really. There's no outlier here. Nothing is like completely off the charts from here. If there was like one here, like said 19 or 20, yeah, there would be an outlier. So no outlier here. All right, so this is a histogram. Now let's do dot plot. In a dot plot, it's like a bar graph. Instead of with bars, it's with little dots. So here's a dot plot. So 0 gets a dot. 1 gets 2 dots. 7, 8, 9 get dots. And 12 gets a dot. So this is a dot plot. All right, so from this dot plot, so let's make it key, each dot equal 1 student survey or 1 person survey. From this one, is there a peak? Look like there's a peak at 1. So there's a peak, so it is between 0 or 1. Is there a gap? Yep, does look like there's a gap between 2 to 6 and 10 to 11. So, or 2 to 6 or 10 to 11. Is there symmetry? Definitely not. Is there a cluster of numbers all grouped together? Not really. I mean, I guess you could tell from 7 to 9, there's a cluster of numbers. And from 0 to 1, but from here, not really. I can't say there's a cluster, like a whole grouping of numbers. And last but, is there an outlier? No, there is not. Last but not least, let's take the numbers again. You know what? I'm going to recopy this number onto the box plot because I hate sliding. 0, 1, 1, 7, 8, 9, and 12. So in a box plot, you have to find the median. That is going to be 7. You have to find the median of the lower half, which is 1. The median of the upper half, that is 9. You have to find a minimum and a maximum. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'll put 1 here for 12. So you draw a dot for the minimum. You draw a dot for the maximum. You draw a dot for the median, which is 7. You draw a dot for the quartile 1, which is 1. And then you draw a dot for quartile 9, which is 1. Then you drown the quartile 1 and quartile 3 with a box, and this will be a box. And connect, connect. This is our box plot. Whoa, look at this huge spread between 1 and 7. Does that mean there are more information or more data in here? No, it's the same like everything else. 25%, 25%, 25%, 25% of the data is there. So, all right, yeah. All right, so yeah. So we already described our data. So now let's take some questions and let's interpret other one. So here's a histogram. Again, a histogram is like a bar graph where you have a range of numbers. What can you tell me about this? It is about carnival profits, I guess in Brazil. Or, is it maybe just a fall carnival? There's a gap between 0 and 99. No, there's not. There's actually something there. False. The shape is symmetrical. I think so. If you split it down here, it looks pretty symmetrical. Not exactly, but it looks pretty symmetrical. There's a peak on the right side. No, the peak is in the center. False. There are no clusters. False. There's a cluster right here. There's a grouping of numbers right here. So that is B is the answer. The histogram shows the number of books checked out by members during different visits to Fairview Library. Which statement is true? There are no gaps and no outlier. That is definitely true. There is no gap. The shape is symmetrical. No, it's not. This is higher than that side. There is a cluster from 9 to 12. Actually, there's a cluster everywhere. They're all grouped together. There is a peak on the left side. It's right here, but I can't say it's really the left side. It's more in the center. So F is the answer. Next one. The dot plot shows the number of hours students sleep each night. Which best describes the shape of the data? How would you describe this? Well, before I'm going to look at it, God, it seems like everything is more skewed to the right. It is symmetrical with outliers. It's symmetrical with no outliers. The data is centered around the third quartile. It is not symmetrical. I will say the answer is D. It does not look like symmetrical. If it's symmetrical, then this will be higher and this will be down. So it's not symmetrical. So I will say the answer is D. And the reason why I would say it's not the third quartile, as you see, most of the information are front-loaded, or in the front end. So most of the data are in the lower half instead of the upper half. All right, in this one, the data is symmetrical. Well, it does look symmetrical to me with an outlier. An outlier, again, is a number that is outside the norm. It's completely by itself. Do you see any numbers outside by itself? So give me, I think it's B. The shape is symmetrical without an outlier. Is there a peak on the left side? No, it looks the same. Is there a peak on the right side? No, everything looks the same. So B. And these math score is pretty symmetrical. That means 25% of the class got 60, 70, 20% got 70, 80, 25% of the class got 80, 90, and 25% got 90, 100. So it was very evenly distributed among the class in the different grades. So what we learned pretty much is there's a gap. A gap is an empty space, like here. There's a cluster, meaning a grouping of numbers. Peak is the highest point, and outlier is something by itself. And symmetrical is like this one, where if you split it out in the middle, the left looks like the right. So that's how you can describe graphs. All right, that is shape of data distributions.